We're continuing our discussion of alternating series, and we're talking about the alternating series error bound or the remainder. This is little notebook worthy for sure, and I usually call this the error bound, just so you know. Um, and this will be an important one, and then we'll have the Lagrange error bound later on for other series. And the error will be less than or equal to your next portion of your alternating series. So the next neglected term. That's kind of the important part. The Lagrange will be very different. So make sure you do understand the difference between these, please. We're going to approximate the sum of the series by its first 6 terms, and then we'll discuss the error that occurs with this. First, I would like to go ahead and talk about the convergence and or divergence because it's our first factorial piece. To begin, we're going to look at the limit as n approaches infinity of 1 over n factorial. N factorial approaches infinity for sure, and 1 over infinity is 0. Our first condition's met. Now we need to determine whether the next term is larger or smaller. So we're comparing the next term to the current term. Again, I would cross multiply. So that's n factorial and n plus 1 factorial. N plus 1 factorial can be expanded into n plus 1 times n factorial. At that point, if you were to divide, then we have 1 and n plus 1. And obviously, as n is greater than 1, we have this going on. Therefore, in general, we know that we're decreasing because the next term is less than or equal to our current term. So therefore, we're decreasing, so we know our summation of n equals 1 to infinity of negative 1 to the n plus 1 over 1 over n factorial converges by our alternating series test. Now we're going to go on to the error part, the actual part for this problem. We're going to find the sum of the first 6 terms. That is the summation of n equals 1 to 6 of negative 1 to the n plus 1 times 1 over n factorial. I used a calculator to get my approximation by typing in that series, and I got 0.632. If you have questions about where the factorial is located on your calculator, reach out to me, please. Our error is equal to a sub 7, the 7th term. So that's 1 over 7 factorial, which is approximately 0.0002. Meaning that the actual sum for the series minus the sum of the 6th term is between, and at this point we're going to take our 0.632 and subtract this 0.0002 and get our 0.6317, and it's bounded on the top, so this time we're going to add, and we're at 0.6321. So we're bounded between those two values, and this is our error, just so we're aware. So our error is the next neglected term, and in this case, that's 1 over 7 factorial. In our next example, we're going to basically solve for when our error is less than 0.001 or 1 over 1,000. To do this, we need to figure out the non-alternating portion. So that's 1 over n to the 4th if we pull out the non-alternating portion. And we know error is equal to a sub n plus 1. So that would be 1 over n plus 1 to the 4th power then in general. And that has to be less than 1 over 1,000. At this point, we're going to cross multiply and begin solving. If we cross multiply, we get n plus 1,000 less than n plus 1 to the 4th. This point to solve, we should take the 4th root. And the 4th root of 1,000, and that cancels, so we subtract 1, must be less than n. And we get 4.6 must be less than n. So the 5th term is the one we're looking for then to give us an error less than 1 over 1,000. And the sum of the 5th term would be the summation of n equals 1 to 5, negative 1 to the n plus 1 over n to the 4th, and that yields approximately 0.9475. And then if you wanted to find your error bounds, you could. Hopefully this is making sense. Reach out to me if you have questions. Just know later on we'll really heavily rely on error bounds. Right now we're just kind of dabbling with the concept. Here's your homework assignment. Reach out to me if you have questions. I really appreciate you taking time out of your day to watch this video series. Thank you.